Pick up a Pringle. Look at its shape. That perfect saddle curve. That's a hyperbolic paraboloid, a mathematical impossibility in nature. Every single Pringle is identical. Exactly the same curve. Exactly the same thickness. Exactly the same crunch. How do you manufacture mathematical perfection at 500 million chips per week? The engineering question. But here's what nobody tells you. Pringles aren't potato chips. They're only 42% potato. The rest? Cornstarch, rice flour, wheat starch, and vegetable oils. The FDA ruled in 1975 that Pringles couldn't be called potato chips because they're made from dough, not sliced from whole potatoes. So what are they? Engineered food architecture? The structural challenge. If moisture content shifts by 1%, the dough won't hold its shape. If frying temperature drifts by 5 degrees, the saddle collapses. If stacking pressure varies, chips crack inside the can. This isn't snack food. This is precision manufacturing at microscopic tolerances. Zero margin for error. 500 million times per week. Signature moment. Inside the system. Today we step inside the saddle-shaped snack machine, where mathematics, chemistry, and engineering converge to create the world's most perfectly stackable chip, from potato to powder. The process begins not with fresh potatoes, but with dehydrated potato flakes. Why? Fresh potatoes contain 80% water and vary wildly in starch content, sugar levels, and texture. Consistency is impossible. Instead, whole potatoes are processed into flakes at separate facilities. Stage 1. Washing and peeling. Potatoes arrive in bulk. They're placed in a hydro washer. Agitated water removes dirt. A rotating drum with rough surfaces gently peels away skin. Stage 2. Blanching. A quick hot water bath softens potatoes and preserves color and flavor by deactivating enzymes that cause browning. Stage 3. Cutting and cooking. High-speed blades chop potatoes into small cubes. They're cooked until soft, then mashed into a paste. Stage 4. Dehydration. The potato paste is spread thin and dried into flakes. These flakes contain exactly 7% moisture and can be stored for months without spoiling. This is the Pringles advantage. Consistent raw material every single time. Dough engineering. The Pringles factory, those potato flakes become dough. The recipe: 2/3 potato flakes, 1/3 water, plus cornstarch, rice flour, wheat starch, emulsifiers, salt, and dextrose, a sugar that promotes browning during frying. Industrial mixers blend ingredients in precise ratios monitored by load cells. Consistency must be perfect. Too dry and the dough cracks. Too wet and it won't hold shape. The dough is fed through heavy-duty rollers applying 4 tons of pressure, compressing it into a thin, uniform sheet exactly 1.5 millimeters thick. This isn't rolling pin pressure. This is industrial force creating molecular-level uniformity. Temperature is controlled throughout. Keep the dough at 60 to 65 degrees Fahrenheit. Too warm, and it becomes sticky and unmanageable. Cutting the dough valves. The dough sheet travels along a conveyor toward a cutting machine. A massive rotary cutter stamps out oval shapes, nicknamed dough valves by factory workers, a playful twist on ovals. Each dough valve is identical. Same dimensions, same thickness, same weight. Here's the clever part. Leftover dough between the cuts isn't wasted. A separate belt pulls the scrap dough away and feeds it back into the mixing stage. This recycling loop minimizes waste and keeps production efficient. Nothing is thrown away. Every gram of dough becomes a Pringle. The cut dough valves continue their journey toward the fryer, where they'll transform into that signature saddle shape. The hyperbolic paraboloid fryer. This is where mathematics meets snack food. The dough valves are placed onto curved molds, each one shaped like a saddle. This shape is mathematically known as a hyperbolic paraboloid. Why this specific curve? It's the only shape that allows chips to stack perfectly without breaking. Flat chips would shatter under stacking pressure. Round chips would roll and shift, but a hyperbolic paraboloid distributes force evenly, creating structural integrity. The molded dough valves are submerged in hot oil at exactly 392 degrees Fahrenheit, 200 degrees Celsius for precisely 11 seconds. Why 11 seconds? It's the Goldilocks zone. 10 seconds and they're undercooked, soft and pale. 12 seconds and they're overcooked, dark and brittle. During frying, 2 things happen. 1, the shape locks in. Heat causes starches to gelatinize, then crystallize as they cool, creating permanent rigidity. 2, moisture evaporates. Water content drops from 60% to about 2%, giving Pringles their signature crunch. As chips emerge from the fryer, hot air blowers remove excess oil, reducing temperature to 104 degrees Fahrenheit and preventing greasiness. Seasoning science. Freshly fried chips travel along conveyors toward the seasoning station. Here's a Pringles secret most people don't know. Only the top side gets seasoned. Unlike traditional potato chips that are tumbled in barrels to coat all sides, Pringles are seasoned in a one-way cascade. Why? The saddle shape. When chips stack inside the can, seasoning from the top transfers to the bottom of the next chip. Over 5,952 pounds of seasoning are used daily at a single factory. Flavors range from original to sour cream and onion to BBQ to obscure regional varieties like seaweed in Asia or ketchup in Canada. Each flavor uses a precisely calibrated blend. Sensors weigh seasoning distribution in real time, ensuring every chip receives the exact same amount. Quality control, red light testing. Every batch undergoes rigorous inspection. Samples are pulled randomly throughout production and taken to a dedicated testing room. Here's where it gets interesting. The room is lit entirely in red light. Why? Red light masks the color of the chips, preventing inspectors from forming preconceived notions about whether they're raw, overcooked, overseasoned, or underseasoned. Inspectors taste test samples against a perfect reference batch, comparing texture, crunch, flavor intensity, and salt balance. Pringles facilities conduct up to 7 million quality checks per year. That's 19,000 tests per day. Being a chip taster might sound like a dream job, but it comes with intense responsibility. One bad batch can spoil thousands of cans. Stacking and the iconic can. Thanks to their hyperbolic paraboloid shape, Pringles naturally stack together. As chips travel along conveyors, they fall into neat, perfectly aligned piles. No manual arrangement needed. Physics does the work. Automated scales weigh each stack, ensuring every can contains the exact same amount by weight, not count. Fun fact. A standard Pringles can contains approximately 100 to 110 chips, depending on flavor and moisture content. The stacks are gently pushed into cylindrical cans, made from paperboard tubes lined with aluminum foil to prevent moisture and light from degrading the chips. The foil lining was invented by Frederick Bauer, the chemist who designed both the chip shape and the container in 1956. Bauer was so proud of his creation that when he died in 2008, his family buried some of his ashes in a Pringles can. "We need to use the original," his son said. "A plastic lid seals the top. The metal base is applied last. Total production time from dough to sealed can, about 20 minutes. Global scale and the $3 billion machine. 5 factories worldwide produce Pringles 24/7. Jackson, Tennessee, USA. Mechelen, Belgium. Johor, Malaysia. Kutno, Poland. Fujian, China. They manufacture over 500 million chips per week. That's 26 billion Pringles per year, more than 3 chips for every human on Earth. Pringles generates over $3 billion in annual revenue, making it one of the top 10 best-selling snack brands in the United States. With over 160 flavors globally, Pringles has become a cultural icon, not just a snack, but an engineering marvel. From dehydrated potato flakes to hyperbolic paraboloid molds, from 392 degrees Fahrenheit fryers to red light testing rooms, Pringles represent the intersection of mathematics, chemistry, and precision manufacturing. A chip fried for exactly 11 seconds, a shape that defies nature, a stack that never breaks. Once you pop, the engineering doesn't stop. Next episode, how Oreo achieves perfect cream-to-cookie ratios at 500 million cookies per day. Subscribe for more deep dives into the industrial engineering behind the world's most iconic products. Thanks for watching.